Hey guys, welcome to the intermediate Python course for Codivate. This is the first lesson, which shall be a review of Intro to Python and what you learned in the Intro to Python course. So the first thing that was covered was variables as well as printing. So what are variables? Well, variables are simply things in Python that hold values. So for example, x is a variable that holds the value 15 in this image. And in the second line, you can see x is again redefined or reassigned to hold the value hello. So as you can see, a variable has two parts, a name and a value. The name is how you access it, and the value is what the variable actually holds. So in Python, there are a number of primitive types, but the four main ones we covered was int, float, string, and boolean. So examples of integers are basically any whole numbers. So 5, -4, 0, those are all examples of integers. Examples of floating points, also known as decimals, include -3.4, 16.4, and 100.0. 100.0 may not look like a float because you may think, okay, that's just 100. But because of the fact that we have the 0.0, it is in fact a float. It's not an integer. Then examples of strings. Remember, strings are basically text. We have hello, world, and empty, an empty string. Also note that it doesn't matter if you have single quotes or double quotes as long as you're consistent on both sides of the text. Next, we have booleans, or shorthand for bool, and those are basically just true or false. Those are the only two possible values for booleans, and it's also important to note the capitalization. In other programming languages, it's possible that the true and false are lowercase, but in Python, the T and the F are both uppercase, which is very important. If you were to lowercase in code, it wouldn't work. Then we have printing. Printing is how you send information to the console. So we can print out strings. We can also print out variables and objects and everything else like that. So this line here, print hello world, will print the text hello world to the console, and we can see it be displayed to us, the user. Then we talked about operators in our Intro to Python course. Python has many operators, but the 7 we covered was addition, which is done by the plus operator. Now this is fairly straightforward. Mathematically, with two numbers, the plus will add them up like expected. 5 plus 2 is equal to 7. But if we were using two strings, it would perform concatenation, which is basically just a fancy way of saying it'll join the two strings together. And then we have the minus sign or subtraction, which again mathematically will result in the difference of two numbers. We have multiplication, which is used by the asterisk, which multiplies two numbers. There's floating point division, and what that means is it's strict, it is division, so 5 divided by 2 will result in 2.5. And this may seem obvious from a mathematical standpoint, but it's important that we denote the difference between 1/ and double/, as you can see in the bottom one. Double/ actually is called integer division. So it'll only take the actual quotient. It won't take the remainder. So 5 divided by 3, even though it's technically 1.6 or 1.6 repeated, Python will only take the one part. It won't calculate the extra bit. So that's integer division. That's the difference between integer division and float division. Then we have modulo, or remainder. So 5 mod 3, what it'll do is it'll divide 5 by 3. You get 1 remainder 2. And so 2 is your result of 5 mod 3. It takes the remainder. And lastly, you have the exponent, which is star star. Basically just raises the first number to the power of the second. This is also useful for stuff like square root, because you can do 2 to the power of 1/2, and that will calculate the square root. So it's not restricted to only integers. After that, we covered how to get user input. So we already discussed how to output stuff to the console using the print function, but the input function can be thought of like the opposite of that. What the input function does is it gets stuff from the console. So you can type in stuff, it'll wait for the user to type in stuff, and it'll get that result as a string. So for example, in the image, you can see enter your name, which happens as a result of this prompt. So the string you pass into the input function is known as the prompt, or essentially what you're asking from the user. So you have this, and then you have the input function, which will wait for you to type something. So this text Codivate was actually typed by the user. And then it just stores that result into the value x, and then it prints your name is and the value of x, which happens to be Codivate in this example. So this is how this output corresponds to the code we wrote. And it's important to note that the input function always returns a string. So if we were to write enter a number and they type the number 5, it wouldn't give back 5. What it would do, it was give back the string version of 5. So basically 5 inside double quotes. And that's an important difference, because if you were to try to add that to, let's say, the number 5, you would get an error because you can't add a string and a number together. It's an important distinction. You would have to cast it using the int function. Then we covered if, else if, and else statements, or basically logical flow. So what is the point of if, else if, or elif, and else? Well, these statements allow us to run specific bits of code only if specific conditions are met. So the if statement is the if keyword is after the if statement you write a Boolean condition, what's called a Boolean condition. A Boolean condition is basically just any statement or any expression that simplifies to a Boolean or simplifies to true or false. So for example, x equals 5 and x is greater than 10. In this example, this is a Boolean expression because we know that 5 is greater than 10 simplifies to false. So this first if statement is false. Now, how does an if statement work? Well, it'll only run the code that precedes that follows the colon and that's also indented. Remember, indentation is key with Python. It'll only run that code if the condition's true. So in this case, the condition's false. So then it'll skip to the next else if. It checks if x is now greater than 5. Remember, 5 is not greater than 5. It's equal to 5, but it's not greater than 5. So this is also false. So once again, it won't run the code inside, and it'll skip to the next one. It checks else if x is greater than 0. Yes, it is. 5 is greater than 0, so it prints positive. And what Python does is when it hits the first condition that's true, so if it were to hit this first if, second else if, or the else. The first one it hits, it'll run that, and it'll skip everything after. So it actually won't run this else. So it'll run this elif, but not this else. So it'll only ever run one of these at a given time. So exactly here, it'll print positive because this is the first time the condition is true. Then we covered logical and comparison operators, which were kind of grouped with if and else if statements because they allow you to kind of chain conditions. So the main comparison operators are equals, which is denoted by double equals. It basically checks equality. Then we have the exclamation equals, which is basically the opposite. It's not equals. So it checks if two values are not equal to each other. Then we have the less than sign, the less than or equal to, the greater than, or the greater than or equal to, which works the same as with math. So for example, or those are the comparison operators. And then we also have logical operators, which include and, or, and not. So and basically checks if both sides of the condition are true. So for example, both sides have to be true in this specific condition, x is less than 5 and y is greater than 3, in order for the whole condition to be true. So let's break it down. X is less than 5. This is actually false because 5 is not less than 5. So this side's false. The and requires both sides to be true. But since one of them is false, we already know that this will be false. And then we have the not. The not basically flips it. So the not in front of this condition will take the false result we got and flip it to true. So now it's actually saying if true, print hello. So it will in fact print hello. The or condition works exactly like the and, except only one needs to be true. So even if the second one's false, if at least one of them is true, then it will consider it as true. And you can see by these examples why they work. And like I said, this one prints hello, like expected. Then we covered lists, sets, dictionaries, and tuples. So we already talked about the four basic data types, which included int, float, boolean, and strings. But these are four more that are a bit more advanced, but still fairly fundamental to Python. So what is a list? Well, a list is an ordered collection of items. So basically, you use a list using square brackets, and you separate each element in the list with commas. A list can hold multiple values, so you can have the value 1, followed by the value 2, then 3, then 4. And note that even though in this example all of them are numbers, it doesn't have to be. You can have the text hello somewhere in there, and it would still work fine. A set looks basically the same as a list, except instead of the square brackets, it's curly braces. And a key distinction between these two is that sets are unordered, while lists are ordered. So even though we include 1, 2, 3, 4, it's not really exactly in this order. And then we have tuples. A tuple is an immutable collection of ordered elements. So essentially, this cannot change. X will always be 1, 2, 3, 4. And you may be like, okay, well, isn't that a bit useless? But it actually isn't. There are a lot of key use cases of tuples, which we'll cover in more detail later in this course. And lastly, we have a dictionary. A dictionary is similar to a set in how it's defined, except we also, with every element called a key, we also associate a value. So the key is 1, and the value associated with this key of 1 is Codivate. Then we have a key 2, which is associated with Python. Then 3, which is associated with 12. And note, for both sets and dictionaries, all elements have to be unique. So in this case, if we were to have 1 and 1 both in the same set, it would basically get rid of 1. So it would only include it once. And similarly for the keys in a dictionary. This was covered in intro. And then we covered loops. So for loops, this is the general format for a for loop. It has 3 main parts. It has the variable that'll usually be incremented. For example, in this case, it's I. Typically, you use a short letter like I, and then you have whatever you're iterating through. So it can be like a range, it can be a collection like a list or a set, and then you have the code which actually goes inside, which is indented by 1 level. And essentially, what's happening with a for loop is you want to use a for loop when you want to run a piece of code a certain number of times. For example, in the first case, we want to run it 5 times because we go from 5 inclusive to 10 exclusive. And in the second example, we want to run this code 4 times, 1 for every element in this list X. So although it's not very common with for loops, it's more common with while loops, which we'll get to in a moment. There are certain cases where you can have infinite loops. For example, if you're changing the value of I within this, it might fail sometimes. But all you need to know is that you need to be careful when dealing with loops because it's possible that you might have an infinite loop. Next, we have while loops. So while a for loop was used when we wanted to iterate a specific number of times, while loops are usually when we want to iterate until something happens. So in this case, we want to iterate until we want to iterate while x is less than or equal to 5. So the moment x is not less than or equal to 5, this while loop will basically terminate. And it's very important to actually modify the variable that you're checking within the while loop. Because if you never modify x to increase by 1, then x will always be less than or equal to 5, right? Because 1 would always be less than or equal to 5. This statement changes it to 2, and then 3, then 4, and then 5, and then 6, which would break it. But if we didn't have this, it would always stay 1, and this would run forever. So this is why it's always important to change it. But it's also important to change it in the right way. This line still changes it, but it changes it to be negative. So it'll change this to 0, then -1, then -2, and no matter what, that will always be less than x. or that would always be less than or equal to 5, right? Because we're never going above 5. We're always getting smaller. So those are while loops, and this is an infinite loop. Both of them, or the first one would have been an infinite loop if we didn't have this. But since we have the x plus equals 1, which basically just adds 1 to x, this works. Then we talked about modules and third-party Python libraries, or libraries in Python. And we talked about the random module. So what is the random module? It allows you to kind of simulate pseudo-randomness. And what I mean by that is it's not truly random, because in the end, a computer can only follow a set of precise instructions. And those instructions have to simulate randomness, but it's not true randomness because it's still programmed. So a computer, or the random module, helps you generate a random number. You can use the randint function from the random module to generate a random number. There's two ways of importing, which we talked about in intro. You can import either the function from the module, or you can import the entire module and then call the module or call the function like this. Both ways work exactly the same way. Then we talked about functions. So we've already covered a few functions, like the ones in random, the print function, the input function, but you can make your own functions. And to do that, you use the def keyword or the define keyword. It basically just defines a function. And it has two main parts: the name, which is in this case myfunc, and inside the parentheses you have the argument list, or basically, yeah, it's just a list of arguments that'll be separated by commas. In this case, we only have one. It's possible that you have 0. It's possible that you could have like 10 or something. It doesn't actually matter. But every time you call this myfunc, as you can see down here, we're actually passing in a value which will be assigned to x. So x, in this case, will have the value 10. And then we can run whatever code in here and use the value x. And remember, when we add my number is to x is a number, and you can't directly add a number to a string. You need to first convert the number to a string using the str function. You could alternatively use f strings, which is formatted strings, but this way works perfectly fine. Also note that we actually did this on purpose. Myfunc. My is lowercase and f is capital. So this is what's known as camel case, and it's very popular in most programming languages. However, in Python, we do it differently. We use snake case. So we actually put everything lowercase, and we separate words with underscores. So my underscore func with everything lowercase, as you can see in this bottom corner. And this is a separate way of naming stuff. It's convention. It doesn't matter. So this code still works, but it's more of a convention to do it all lowercase with snake case. Then we talked about return statements within functions. So you can actually send information back from outside the function. So in this case, we have myfunc, which now we fixed it to have camel case. It takes in 2 parameters, and it returns their sum. This is a pretty trivial method, or pretty trivial function. However, it still works as expected. Print x will actually print 15, because 5 plus 10 will result in 15, as per the function definition. And then we have a set of exercises. Our exercises include making a list of 50 random numbers ranging from 0 to 10, and print out the sum. So this will require you to use what you learned from the random module, as well as using stuff like loops to solve this. And our challenge is to try to solve this using both a for loop and a while loop. It might be a bit easier to do it with a for loop, but try to do it as well with a while loop. Our second challenge was to create a function that takes in a list of elements and returns, assume the list of elements contains only numbers, and then it returns the largest element in that list, which is a multiple of 3, but not a multiple of 9. So if our list contained 3, 6, and 9, then what we would have to return is not 9, we would have to return 6, because 6 is the largest number in that list, which isn't a multiple of 9, but is a multiple of 3. And if no such element returned, so for example, if all our numbers were prime and none of them were multiples of 3, then you could return something like -1. And then our final exercise was to ask the user for their grades, and we would want to print out what their letter grade is. So if their letter grade was an F, you would have to print out F. And you would have to continuously ask them for their grades using the input function and using a while loop until they say, I have no other classes left. And at that point, you want to print an average of all their grades. This one's a bit tricky, but it's perfectly doable if you've grasped these concepts. So this is our exercises, the 3 challenging exercises we created for reviewing intro. And this presentation was created by Codivate. If you have any questions, you can email us at internpi@codivate.org. However, if you want a really fast reply from your tutors as well, we highly recommend you check out our Discord and ask help for tutors from there, because they're readily available to help you out there. All right. So thank you for listening, and I will see you next week with our next video.